So file sizing. Basically, file sizing means this is not about the database file. This is about non-database files that we will create in the programming language of our choice or in pseudocode. All right. File size calculation. So what basically happens that you are given a scenario, you will have to choose the data types. According to those data types, you will choose the size of the data type. And then we will find the size of a record. And then we will see that how many records are there. We will find the size of the file. And then at the end, we will discuss about the fact that when the file is in the RAM, the size is basically the actual size, but when the file is saved over the disk, the size of the file inflates. So when the file is over the disk, it is bigger in size than the same file when it is in the RAM. So if you load a file from the disk in the RAM, the size of the file will shrink, and when you will save the same file over the disk, the size will grow. We will discuss about the reason, but since that reason is not the part of this particular lecture, I will just discuss a little about it, but I will let you know. So let's see. So first of all, you need to remember the size of the types first. Okay. So Boolean is 1 byte, character is 1 byte, date time is 8 bytes, integer is 4 byte, real is 4 byte, string as many required. But you don't have to write as many required in exam. You would have to decide that how many. Since the thing is that a string might be for a memo which is more than 100 or maybe 100 characters, might be a name which we don't think that would go beyond 20 characters, might be an address that you think might go up to like 30, 40 characters, might be a class name, let's say ASC. So there are 3 characters, there is a hyphen in between, then 4 characters. So you would have to actually check the scenario, the type of the data which is being saved in it, type not as in the type to choose from these lists, but the example of the data that was given to you, and you will choose that as the example to decide for the size of the string. Okay, so this is one thing that you have to remember. I have seen students, since I say as many required, they write as many required. No, you would have to choose the number of characters that would go. And these characters also include spaces. If my name is Zafar Ali Khan, I would have to actually include those 2 spaces between Zafar and Ali and Khan. All right. So another thing, when you will look into past papers, there might be different sizes mentioned, but remain assured that these sizes are proper. And if it is in marking scheme, you will see that different scenarios are given. I've seen students using 1 byte slash 2 bytes for Boolean. So the thing is that few teachers considering Unicode as the code underhead, they choose 2 bytes for Boolean. That is fine. But you would have to actually make one standard for yourself and stick to it. Your syllabus does not require you to choose from one aspect of it. Whatever that you are choosing should be the constant. All right, do not get confused about it. I'm giving you these sizes. Keep these sizes in mind. And if you look into marking a scheme and if there are other options, remain assured these would be one of those options. Okay, so let's start. Now, basically, let's take this May-June 2011 P23 question. This question says that Amber stores the name of her favorite songs in an array. She has 56 track names at the moment and expect to reach 150. So it means that total number of records that we will have will be 150. She defined the array as one-dimensional, size 150, and will store strings. She then initializes each element of the array. We will discuss about initialization later. As her collection grows, Umber decides to hold more information about each track. The data for each track is structured as a record. We just discussed record in our previous lecture of data types and records structures. Each record contains following data: unique track ID, a whole number between 1 and 150. Unique track ID would be integer. Size of the field is 4 bytes. As you can see, they have already mentioned bytes over there, so you don't have to write bytes yourself. Number 2, track name. Track name is a string. All right. So string, and now you will have to decide that how long that string might be. Okay. So let's say a track name would not go beyond 15 characters. So I have chosen 15. Then it says date bought, when it was bought. So it is date. I told you that these are 8 bytes. Then cost. Cost is real. And it is 4 bytes again. Is it solo artist? Yes or no? So this would be Boolean. So this is 1. Now what you have to do, you will have to actually find the size of the file for 150 records. You see, there are 10 marks allocated for it. So first what we will do, we will total this up, that how many bytes are there for one record. How many bytes are there for one record? So this is 4 plus 15 plus 8 plus 4 plus 1. So this is 32 bytes. So one record is equal to 32 bytes. If there are 150 records, it means it is 32 multiplied by 150. So 32 multiplied by 150 will become 4,800 bytes. Calculate ASP1, that how to find kilobytes or TB bytes. So you will have to actually find kilo out of it. So that will be 4,800 divided by 1,024. Okay, so that will be 4.69. TB byte. Now, the thing is, this is the actual file size. Remember, when the file is in the RAM, it is in one of the data structures, like array. But when the file is saved over the disk, it is no more in array. This is in file form. So when the file is actually saved, it is inflated. There's a science behind it. Let's discuss that science first. What basically happens that when we save the data to the disk, let's take an example of magnetic disks. Okay, so these disks are having tracks, and then these tracks are having sectors on it. So this one part over here that you see is basically a sector. Each sector has got 512 bytes in it. So let's take this sector in the bigger form. This sector has a little part of it which is called housekeeping. This little part does not allow the sector to save complete 512 bytes. All right, so what basically happens that if let's say a file is of 1024 bytes, it won't be divided into two parts exactly because a little part of every sector is basically taken by housekeeping. So this 1024 bytes file will be saved over three sectors rather than two. So you can see that the size of the file is inflated by 50%. This file will be saved over 512 bytes sector. So this would be 1.5K. The original size of the file was 1K. All right, so this is an example for you to understand that when the file is saved over the disk, it inflates. Now, this 50% inflation is basically not the purpose over here. It is just for your understanding. So for your syllabus, it is understood that the file, when it is saved, it is inflated by 10%. 10% is fixed. All right, so mind it, 10%. So whenever there is a question of the file size, you will calculate the file size, but that calculation will be actual file size. So what you will have to do, you will have to actually 10% to the original file size before claiming it to be the file size in so 4800 multiplied by 1.1. 1.1 as in 10% inflation. So this would become 5280 bytes. Then you divide it by 1024. So this will become 5.16 kilobyte. Right? So this is basically the file size that you will have to write. So that's about it. File size. In file size, first you will have this gray differentiable. You decide for the data type, and according to the data type, you will decide for the field size. The string will actually make you think about it. What should be the number of characters for the string? Once you decide upon it, then you will have to calculate like how many bytes are required to save a single record, and then you will have to find out from the question, from the given question, that how many records are there. Once you find the number of records, what will happen that you will have to multiply one record size with the number of records in it, and then you will find what the size of the file, but that size of the file will be actually the size in the RAM. So then we will have to actually add housekeeping. So this is which is 10%. 10%. Okay. So once you at least 10%, then we will find the size of the file over the disk.